All right, so for number 19, if you look at the three graphs, now you were given the graph of h of x, which is this one right here, and then I just plugged f of x into my y1, and this is the graph I got. And then g of x, it tells you to take the f of x equation and minus 2. So here's the new g of x equation. I plugged that into my y1, and this is what I got. And they're talking about odd and even. Now remember, if something's odd, it's symmetric with respect to the origin. In other words, you can just turn your picture upside down, and it's the same picture upside down as it is right side up. So that means that f of x is odd. Now g of x, if you turn that upside down, that is not odd. So the only other option is for it to be even, potentially. And even means if you reflect over the y-axis, in other words, if I fold here, does the left side of my picture here match up with the right side of my picture? And no, it does not. So that means that it's not even. So if it's not odd and it's not even, then this is a neither. Now let's look at the one that they gave you. They gave you h of x. And if you look at h of x, you can see that if I reflect over my line, the y-axis, you can see that the left-hand side of this graph right here will match up with the right side of the graph there. So that makes that function an even function. So h of x is even. Okay, so knowing all of that, if you look at choice 3, it says f of x is odd, g of x is neither, and h of x is even. So the answer is choice 3. Okay, so 20 wants you essentially to do the same thing as number 19, but we just have to do this algebraically. So remember that if something is even, the rule is that f of x equals f of negative x. And if something is odd, then remember that the rule is f of negative x equals negative f of x. All right, so those being the rules, let's start by finding f of negative x. So everywhere you see an x in the f of x, you're going to replace it with a negative x, like that. And plus 2, I see an x, so I'm going to put in a negative x, and I will cube that. Minus, and I see an x, so I'm going to plug in a negative x. And let's work this out. So f of negative x equals, I'm going to bring down this negative. Now, let's talk for a second here. I have a negative, but raised to the 5th power. So that's a negative times a negative times a negative times a negative times a negative. And you should remember that an odd number of negatives multiplied together will still give you a negative. Okay, plus, and then same thing again, an odd number of negatives will still give me a negative. And then here I have a negative times a negative, which will make a positive. All right, let's just go one more step. So here I have 2 negatives, that's going to make a positive. Okay, so that's going to give me a positive x to the 6th. And then we have minus 2x cubed, and then plus x. What am I saying, x to the 6th? What? Let's try that again, x to the 5th, I'm sorry. Okay, now let's just check the even rule for a minute here. And I notice, and I'm going to rewrite the original function underneath here. The original function is negative x to the 5th plus 2x cubed minus x. So in order for this to be even, these two guys would have to be equivalent to one another, right? Which they're not. So this is definitely not even because f of x is not equal to, I'm sorry, I can't fit it, so I'm going to write it down here, f of negative x. I'm sorry, negative f of x. All right, so now let's test for odd. Okay. All right, now odd, let me just write this. So odd is f of negative x, which we already did in this first part here. And I'm just going to rewrite it. It's x to the 5th minus 2x cubed plus x. Now we're going to try to see if that is equal to negative f of x. Well, negative x is really pretty easy, negative f of x, I mean. And basically all we're going to do is we're going to take the original equation and we're just going to negate it. So look, here's the original equation right here. So we're going to negate this, and negate this, okay? All right, so let's see what that ends up giving us then. So that would give us a positive x to the fifth. Then that will end up giving us a negative 2x cubed and a positive x. And then we do see that these two guys here are the same. So that means that these are odd because negative f of x equals f of negative x. And that's how you would show it algebraically. So I think the easiest way to probably tackle this problem is to just go one by one through each choice and plugging in a number into this equation they gave you. So if you look at choice A, it says B has to be greater than 1. So just pick a number greater than 1, like 2, okay? And put in y equals 2 to the x in your calculator, in your y1, and see what that picture looks like, okay? And when you do that, it's going to look like that, which does not match the graph that they have. All right, so then let's go to choice B. Now choice B says to pick a number right here. It says to pick a number between 0 and 1. So how about like if B was 1/2? When you plug that into your calculator, so in other words, you're just plugging in f of x equals 1/2 to the x in your y1, you will actually get a picture that looks like the one that you're given. It looks like that. So then the answer is choice B. Now, you can check for choice C, and if you're choosing something less than 0, that would have to be a negative number, right? So like negative 2 to the x. And you'll find out that your picture does not look like the one that's given. It looks like that, okay? And then again, you can do the same thing for choice D. And we want to pick something less than negative 1. Well, that's kind of like we could pick the same thing that we did in choice C, right? Because negative 2 is less than negative 1. Okay, and then again, I'm just repeating myself here, but that's what that looks like. All right, so the answer is choice B. Okay, well, part A is really pretty easy. I would just take that equation, plug it into my y equals, and see what that picture looks like. So when I do that, I end up getting a picture that looks like that. So that is definitely a decay because the graph decreases over time. Okay, so as we go from left to right, that graph is decreasing. All right, so then part B asks you to describe the end behavior of h of t. So remember end behavior. So that's as t goes to negative infinity, and then also as t goes to positive infinity. Now t is representing x, okay? Now remember, as t goes to negative infinity or t goes to positive infinity, we have to look at the y value. Now we don't call it y because they are saying y in function notation. So we're going to write h of t goes to, and h of t goes to. So we're going to see where they end up going. All right, so let's look. So this says as t goes to negative infinity. So this is as the x values get smaller. In other words, go to the left. So here's my x-axis, and let's look at what the graph is doing. As it goes further to the left, do you see that the y values are going higher and higher and higher and higher? So then that would mean that our y values are approaching positive infinity. You don't have to write the positive in front of it, but you can. All right, so then let's look at the second part. So this says as t goes to infinity. So in other words, as the x values get larger as we go further to the right in the graph. So let's start in the graph. Here we go. Let's go further to the right, further to the right, further to the right. What are happening to our y values? Do you see that our y values are going lower and lower and lower? Now, let's ask a question though. Are the y values going to go all the way down to negative infinity? In other words, they have to cross over this x-axis. And no, that's not the case. They're not going to cross over the x-axis because the x-axis is an asymptote. So in other words, the graph gets closer to the x-axis, but it will not cross over it. So then the lowest y value that this graph can go toward would just be getting closer and closer to 0, but not touching it. Okay? So then our answer here would be 0. 23 asks you to take the equation that they're giving you, and it wants you to write its inverse. Remember, this is the notation for inverse, and it says it also right here. Okay, remember the shortcut, really the easy way of doing inverse is just switching your x and your y values. So instead of writing f of x equals, I'm going to write x equals 1/2, and then instead of writing x, I'm going to write y minus 3/4. Okay, now that is your inverse equation, but remember we always want our inverse equation to be solved for y. So I'm going to try to get the y by itself. So I'm going to start by adding 3/4 to both sides. That'll help isolate that y a little bit. So that's going to be gone. So then we have x plus 3/4 equals 1/2 y. All right, now I want to get rid of that 1/2. So remember, the way we can get rid of a fraction is to multiply by its reciprocal. And what I do to one side, I'm going to do to the other. But please notice I put the parentheses around both the x and the plus 3/4. So the 2 that I'm multiplying over here will come over here, but in front here we have to multiply it by everything. Okay, so that would be 2. And that's going to cancel out the 1/2 on the right-hand side. Okay, so then on the left-hand side, how about we just, we could just leave it, couldn't we? 2 times x plus 3/4 equals y. Right? We can distribute it through if you so choose. That's completely up to you. You don't need to. But before I do, I'll show you how to distribute it through if you want to. But it does ask you to write an equation for the inverse, and this doesn't really say that. So I'm just going to change this. Oops, that's supposed to be a 3. Equals f inverse of x. Okay, so there's your answer. Now, if you so choose and you want to distribute through, which it doesn't say that you need to write things in simplest form or anything, but you can distribute the 2 through, and then 2 times 3/4 would be 3/2, and that would equal f inverse of x. Okay, so either one of these that I boxed off are acceptable. They're the same. So they want you to find the inverse, so just like number 23. And just remember, this is just inverse notation. And remember, inverse means to switch the x and the y. So I am going to change f of x, and I'm going to write x equals. And I'm going to change 2x to 2y plus 3. And in the denominator, instead of x minus 9, I'm going to write y minus 9. All right, so I think the easiest thing to do is probably just cross multiply. So this is the tricky one right here. Okay, so on the other side, though, I'm just going to get 2y plus 3 equals xy minus 9x. All right, now, it's a little bit of a mess here, but remember we are trying to solve for y. So what I'm going to do is I'm going to get all of the y terms together on one side of the equal sign. It does not matter which way you move them. So I'm going to leave this one here, and I'm going to move the xy over to the left You don't have to do it that way. I'll show you both ways though, okay? All right, so actually here, we'll do like a little split screen. I'll show you the other way in just a minute, just in case you did this one already and you went the opposite direction of what I'm going to show you right now. All right. All right, sorry for that interruption. So I'm going to just move the XY over and move it over here as well. And at the same time, I'm going to subtract 3 and subtract 3. Okay, so those 3's are going to cross out and the XY's are going to cross out. Okay, now just be careful. I wrote it like this, but these are not like terms. And these are not like terms. So we're not technically going to add or subtract them. We're just going to write them next to each other. So in other words, I would have 2y minus xy equals negative 9x minus 3. Okay? All right, then on the left-hand side, I'm going to factor out a y because both terms on the left-hand side have a y. So let's take that y out. And I have 2 minus x equals negative 9x minus 3. Almost done. Now my y is almost by itself here. I just have to divide by what's attached to it, which is the 2 minus x. Okay? And remember, I'm not going to write y equals because they're using function notation. So I'm going to write f inverse of x equals, and then it would be negative 9x minus 3 over 2 minus x. And there's your answer for the inverse. Okay, now let's say you went the other way. So in other words, if we go back again and we look at what I did here, I moved my xy to the left, and I moved my positive 3 to the right. Okay, so let's say you did not do that. Let's say you did the opposite. Okay, so in this case then, I would subtract the 2y, and I would add 9x. Let's say you did that, which is totally fine. So the 9x's are going to disappear, and so are the 2y's. All right, so then on the left-hand side, I have 9x plus 3. By the way, you could write 3 plus 9x, it doesn't matter. And on the right-hand side, I'm going to have xy minus 2y. Okay, well, similar to what we did over here on this step, we took out a y. I'm going to do the same thing here. I'm going to take out a y. So let's just drop down the 9x plus 3 for right now. Let's take out a y, and I'm going to get x minus 2. Then to get the y by itself, I divide by x minus 2. And then you see, I'm not going to write y equals because they're using the function notation, but f inverse of x equals 9x plus 3 over x minus 2. So that's the other option. And I want to just, I know we've gone over this in class, but I just want to show you the similarity between what's boxed in both of these. You have complete opposites, really, is essentially what you've got. Here you have a negative 9x. Here you have a positive. Here you have a negative 3. Here you have a positive 3. Here you have a positive 2. Here you've got a negative 2. Here you've got a negative x. Here you've got a positive x. As long as all 4 signs are completely opposite of each other, both answers are correct. So you don't ever need to worry about that, but all 4 signs have to be different. Okay? And that's just because you moved things to one side of an equal sign that maybe somebody else moved to the other side of the equal sign, so it's totally okay. Okay, so we have an equation that has fractions in it, so remember, common denominator. So I see a binomial, x plus 2, and I see a monomial, x. So this x has one term, and this x is part of a 2-term binomial, so they're not the same. So just remember them when we're finding a common denominator. I'm going to go like this, okay, top and bottom. And so then when I get to this middle fraction here, this is going to be tight, but I'm going to have x plus 2. I'm going to have to write it underneath it, I'm so sorry, x plus 2. Okay, and then here it needs an x and it needs an x plus 2. So you smush them together. Okay? And now you should be able to see, although I wrote it kind of sloppy, this is x times x plus 2, this is x times x plus 2, and this is x times x plus 2. Whenever you have an equation and you have all the same denominators, remember what we taught you is that you can just cross out those denominators. So, goodbye. All right, so now we're just going to rewrite our numerators. So I have x times 4x minus 12 times x plus 2 equals, I'm going to drop the 1 because we don't really need that, x times x plus 2. All right, so let's distribute a little bit here. So I've got 4x squared minus 12x minus 24. And then over here I have x squared plus 2x, right? Okay, so I have an equation, and it's a quadratic because I have x squareds in there. So I'm going to move everything to one side and set it equal to 0. So I'm going to move over this x squared by subtracting it, and I'm going to move over the 2x also by subtracting it. And that's just going to get my right side to be 0. So we've got 3x squared minus 14x minus 24 equals 0. Okay, now you have a couple of choices here. You could do the quadratic formula to solve, or you could factor doing the rainbow method. So that's really completely up to you, however you feel more comfortable. I think most of you are probably going to do the rainbow method, so I'll go with that. So we are trying to figure out what multiplies, right, to 72, is that? And we'll add to 14, negative 14. And that would be 18 and 4. Okay, so remember you can always cheat, go to your y equals, and do 72 divided by x. So now remember when we're doing this rainbow method, we bring down the first term, and we bring down the last term. Okay, so we said 18, right? So we've got 18 and 4. Now we need to get a negative 14 when we add those two. So I'm going to put a negative here and a positive there. And we're going to group the first two terms, group the second two terms. So if I take out a 3x, I have x minus 6. And over here on the right, I'm going to take out a 4, and I'm going to have x minus 6 again. So I have 3x plus 4 in one set of parentheses, and I have x minus 6 in the other. So there it is factored. But the question says to solve. So remember when we solve, we do our little t-chart here, and we set each of these factors equal to 0. Okay. Well, this one over here on the right is pretty easy. That's x equals 6. And then over here on the left-hand side, we're going to subtract 4 out. We'll get 3x equals negative 4, and then we're going to divide that by 3. So we have x equals negative 4/3. Now, remember, you want to be very, very careful here, because you want to make sure that neither of these two solutions here will make the denominator of any of your original fractions undefined. So, for example, let's take the easy one. If I put a 6 here, will I somehow get a 0? And no, I won't, because 6 plus 2 is 8. If I put a 6 here, I can't get a 0 either, can I? Undefined means the denominator of a fraction is equal to 0. So since that doesn't happen with x equals 6, we can keep that answer. Let's just do a quick check here with negative 4/3. All right, well, I know negative 4/3 is pretty gross, but if you put it in your calculator, negative 4/3 plus 2, you're not getting 0. And the same thing here. Negative 4/3, again, I know it's ugly, but it's not 0, so we're good. So our two answers are the ones that I circled. Number 26, very similar to number 25, so we're going to find a common denominator. I'm actually going to just rewrite this one because I would like to spread it out a little bit. So, and factor at the same time. So 12, and I see that I have difference of two perfect squares there, so I'm just going to go ahead and write x minus 4x plus 4. Okay, and then that's plus, and then that's 24 over 4 minus x. That's a little interesting. Equals 3 over 1. All right, now let's just think a little bit here, because common denominator wise, I see that I have an x minus 4, but that's not x minus 4. Those guys are opposites of each other. They're not the same thing. With subtraction, for example, if you had 3 minus 5, that's not the same as 5 minus 3. So remember, what we can do here is we can change that to x minus 4 so that it matches. But if we do that, we have to multiply by a negative 1. Remember that? So if we multiply by a negative 1, I think the easiest thing to do is to just take this addition and make it subtraction. And that's multiplying by negative 1. Okay? All right, now, I still need a common denominator. So this x minus 4 needs to get multiplied by an x plus 4 to match the denominator of the first fraction, which then means this one needs an x plus 4, right? Now, this last fraction, well, that needs everything. So that's an x minus 4 and an x plus 4. And the same thing in the numerator, x minus 4 and x plus 4. Okay, so just like number 25, once the denominators are the same, we can get rid of them. All right, so why don't we rewrite this so it looks a little prettier now? So I've got 12 minus, because remember we changed the plus sign to a minus sign, then I have 24 times x plus 4 equals 3. Now, I really have x plus 4 times x minus 4, which is dots. So I'm just going to quickly distribute that out, and I know that that is x squared minus 16. All right, so why don't we go ahead and distribute? So then I have 12 minus 24x, right? And then minus 96 equals 3x squared minus 48. So how about we consolidate a little bit here? So on the left-hand side, I have negative 24x, and then I have minus 84 equals 3x squared minus 48. Okay, so I have a quadratic. I'd like to get everything to one side and set it equal to 0. So I'm going to add 84 and add 84. And then I'm also going to add the 24x over and add the 24x here as well. So that disappears. All right, so then I have 0 equals 3x squared plus 24x. And then that's going to be plus 36. Well, I see that they all have a common factor of 3, so how about I divide out that 3? And that's going to make my life a lot easier. So that's x squared plus 8x plus 12 equals 0. Okay. So that would be x and x. And we are looking for what multiplies to 12 and adds to 8. So that would be 6 and 2, right? Both positive. So we have x equals negative 6, because again, they want solutions, and x equals negative 2. All right, now remember what I said on number 25. You want to be careful and you want to check your answers and just make sure that they don't make the denominator of any of those fractions equal to 0. So let's plug in the negative 6 here. Well, negative 6, if I square that, is 36. And 36 minus 16 isn't 0, so that's good. Here, 4 minus negative 6, that's not going to give me 0 either, so that one's fine as well. Let's check x equals negative 2. Negative 2, if I square it, is 4, and 4 minus 16 isn't 0, so we're good. And lastly, 4 minus, again, I'm putting in a negative 2 here, so 4 minus negative 2, well, that's not 0 either. So both of our answers are good. So our solutions are x equals negative 6 and x equals negative 2. All right, so if you read this question, it asks you to explain how -8, that quantity to the 4/3 power, can be evaluated using properties of rational exponents to result in an integer answer. So you have to write an explanation. It's okay to mathematically show the work, but that's not sufficient for a full explanation. You have to explain in words in conjunction with the math work. Okay, so you may remember power over root, and that's kind of the rule that we're going to apply, but we want to write it in words. So I would start by saying, take the third root of -8. Okay, so if you take the third root of -8, and you can put that in your calculator, you hit the math button, and you go down to 4. There's the third root, and just plug in -8, and you're going to get -2. Oops, let me just fix this real quick. Okay, so you're going to get -2. And so that's essentially what you did to go from here to here, is you took the third root of -8. Okay? The next thing I would do then is to raise -2 to the 4th power. And then when you do -2 to the 4th power, you get, oops, sorry about that, you get 16. Okay, so your final answer would be 16. So again, this explains our first step. So we took the cube root of -8, because we do power over root, right? And we got -2. Then we take that -2 and we raise it to the 4th power, and we got 16. And our answer is an integer answer. Okay, there are some parallels to number 27 when we're looking at number 28, but there are also some differences. So what this one wants us to do is take 3 to the 1/5, that quantity squared, and they want you to explain, so again, we're going to have to use words, how that is equivalent to the 5th root of 9. So when you're doing something like this, you want to manipulate one side of the equal sign but not the other. So I'm going to choose to leave the 5th root of 9 alone and see what I can do on the left-hand side. Well, I know that when I have a power to a power, what do I do with those two exponents? I multiply them, right? Okay, so if I multiply, and you can use your calculator or your brain, if I multiply 1/5 times 2, I'm going to get 2/5. And that is going to be, we're going to prove that it's equivalent to the 5th root of 9. Okay, so then we have to explain what we did from this step to this step. So my explanation would be multiply exponents when you have an exponent raised to an exponent. Okay, so then let's look at what our next step will be. So then our next step is going to be, well, I want to make that kind of look like a radical, right? And I know power over root. So basically, the denominator of my fraction here is the root. And the root is that number right there. And this is my power. So power over root, right? Okay. So let's just show that first. So then I'm going to take the 5th root, right, because the denominator is the root, of 3 to the power of 2. Okay, so look at what we just did. Now let's try to explain that. All right, so then if we look at the second to the third step, we applied the power over root rule, and we take the 5th root of 3 squared, or 3 to the 2nd power. Okay, we're almost there, because hopefully you are seeing it right now, that 3 squared is equivalent to 9. So all we're going to do right here is we are going to keep this the 5th root, and we're just going to square that 3, and we get 9. And then you see that the left side equals the right. Okay, we have to explain that then too. Okay, so if you square 3 that's under the radical, you will get the 5th root of 9. And now your left side equals your right side.